Do you ever get stressed and miss your college learning days? Need an escape from the boring routine of everyday life?
Yes!
Worry not, you can relive those magical moments of your biochem days with our new coloring book. Introducing the coloring book on the citric acid cycle part 2.
Be positive like a proton! You need your coloring book!
The overall purpose of the citric acid cycle is to produce NADH and FADH2 for the electron transport chain, where many ATP molecules are produced. The second part of the cycle, which focuses on our 4 enzymes, is responsible for producing 1 ATP molecule, 1 NADH, and 1 FADH2. Another function is to regenerate oxaloacetate in order for the cycle to restart. You can color and learn all about where the citric acid cycle takes place, how enzymes function, and the order of the cycle in our fascinating coloring book.
Succinyl-CoA synthetase reversibly catalyzes the formation of succinate and GTP from succinyl-CoA, GDP, and inorganic phosphate. GTP is generated through substrate-level phosphorylation from the hydrolysis of a succinyl group to make succinate. The concentration of succinate is kept low to allow the reaction to move forward.
Succinate dehydrogenase reversibly catalyzes the oxidation reaction that turns succinate into fumarate. The alkane succinate undergoes oxidation and loses 2 hydrogen atoms to create the alkene fumarate. These atoms are accepted by FAD to create FADH2, one of the major products of the second half of the citric acid cycle.
Fumarase catalyzes the reversible reaction between fumarate and malate. The conversion undergoes a hydrolysis reaction, which cleaves a bond by the addition of water. Without the presence of water, the substrate will not be able to undergo the mechanism and add a hydroxyl group to the second carbon and remove the double bond in order to form malate. Fumarase does not have any inhibitors. However, another substrate can bind to the active site in order to increase binding rates.
Malate dehydrogenase reversibly catalyzes the oxidation of malate to oxaloacetate. It has a hydrophobic cavity which has a specific binding site for NAD+. There is a conformational change in the active site to allow for binding. The NAD+ is utilized as an electron acceptor and pulls off a hydroxyl group from the malate. The reaction produces 1 NADH. The enzyme is regulated allosterically and is inhibited by citrate.
These enzymes work together in order to allow the following reactions to proceed by creating products that are used as substrates. If the previous reaction is dysfunctional, the citric acid cycle will not continue because there is no substrate to fuel the next reaction.
Once you have completed our amazing coloring book, you can test your knowledge by answering these questions that correspond to a number and a color, then you can use to color this amazing mandala. Be positive like a proton. Buy our coloring book
for $19.99
plus shipping and handling.
Compelling. I'm blind. Is to produce NADH and FADH.
#BePositive.